Good morning, everybody. Today I wanted to record a video here on my walk, but I forgot my camera, so I'm doing it off my phone. That's why you get a little bit of a bigger view of my face. I hope that doesn't bother you. What I wanted to say was I really appreciate all the support everybody's giving me, and all of your messages are much appreciated. I've been having so many nice messages, been receiving so many nice messages lately that I have to say that people, you are really kind, and thank you very much. That really encourages me to do more content, potentially do better content. So today I'm taking a walk, and I wanted to have a little bit of a discussion about databases. I just came off of teaching a planning and designing databases on AWS class, and that class focuses on just the whole portfolio of AWS databases, which, as you can imagine, is quite a lot, right? There are a lot of databases in AWS, and then the question was, there was a question saying, well, but how do I choose which database is right for me? How do I select the right database for my application? All right, before we answer that question, let's talk about what kind of databases we can deploy in AWS. So first, we've got the Rds service. This is the relational database service. It can deploy any kind of relational, typical traditional SQL database. The engines that are supported are MySQL, MariaDB. We've got Postgres, we have Microsoft SQL, and of course Oracle is also supported. Different versions of those engines are supported, so if you have an application that is specific to that engine and specific to a version of that engine, then of course that's your choice. You're locked in. Now, as far as expensiveness, the Rds service is instance-based, so you will define how many instances you want. You will define whether you want to run them in a highly available fashion. You can use multi-AZ, which will deploy your instances in multiple availability zones without you having to manage that. And of course, you also have the ability to run read replicas. Now, read replicas, of course, with these engines are asynchronous. Well, let me back up. Microsoft doesn't support read replicas, because when you make Microsoft highly available, it has a different approach. Either have an active passive cluster with a conductor instance that controls whether the cluster nodes are in sync, and if you're going for a newer version of Microsoft SQL, I think 2016 or newer, if I'm not mistaken, don't take my word for it, it will be always on availability groups, which creates a cluster with one active instance and multiple passive instances that are available as synchronous replicas, near synchronous replicas with millisecond latency. So those are a little bit different. But if we talk about the Rds engine, MySQL, Maria, Postgres, and Oracle, you can do read replicas, and those read replicas are asynchronous. There will always be a lag. You can run your workload against the asynchronous replicas, but if you have a time-sensitive operation that needs the latest data, then you have to go to the primary, right? You cannot address your replicas. Now, because of this, essentially AWS developed Aurora. Aurora is a next-gen sort of engine for databases. So what Aurora does is Aurora has the architecture of Aurora is designed in a way where the database processing and the database storage is decoupled. So you have a processing layer of instances that receive commands and then write commands up to a storage layer, which is a cluster file system, a cluster volume that is created on the back end, and that cluster volume essentially is 6 times replicated. It's in at least it's sitting in 3 availability zones, and you can have one primary instance which has read-write access to that cluster volume, and then you have secondary replicas which are again synchronous. There's potentially milliseconds of latency behind the scenes in the storage itself, but you can consider that synchronous. Okay, so that's your typical relational databases. Now, since you set up instances, since you set up instance counts, the pricing will be based on the instance count. So essentially, when you have, many instances, then your cost will go up, and when you have less instances, your cost can go down. In traditional RDS databases, you can add and remove read replicas as needed. Now, it takes a bit of time for a read replica to become available. It needs to be created and synced with the primary, and that takes a little bit of time. Hey squirrel. Hey squirrel. Hello. Hello squirrel. Squirrel. Anyway, hope that was caught by the camera. I don't know. I'm doing it in selfie mode, so I didn't see what was on screen. All right. The traditional instances, they can become expensive. You're also limited in capacity, right? Depending on the complexity of your queries, you're looking at thousands to maybe tens of thousands of concurrent queries supported on your clusters, and that's a limitation when you have a web scale application that has millions of users. So yeah, next to relational databases, there are non-relational, or sometimes called NoSQL databases. Now, the NoSQL database design is provided to essentially allow us to completely forget about everything that we did in traditional databases, right? So traditional databases are ACID compliant, or ACID. ACID stands for atomicity, consistency, isolation, and durability. Atomicity means every transaction is atomic. If a part of that transaction fails, the whole transaction will fail, right? If you take a quark out of an atom, the atom no longer exists. Consistency, we have consistency built into these databases, essentially ensuring that the data is written at all times in a consistent manner. And that can be done when you're on one instance or when you're replicating. When you're replicating, typically what you want to do is you want to ensure the data is replicated before you make it available. So you put locks on the data when you're changing it. That also isolates your transaction from every other transaction, because you put locks on data. Nobody else can touch that data at that point in time. And then of course durability is achieved by having backups, by having replicas, by having an environment that is highly available across the board. We take that away in traditional, we take that away in when we talk about non-relational databases. And when we talk about non-relational databases, it's more about getting reads and getting writes in at high performance, right? So in the, AWS, we have Dynamodb. It's a key value or document store that allows us to read and write at potentially millions of operations per second. Technically there is no upper limit. There is an upper limit when you talk to the AWS people and say, okay, that's all we're gonna give you for your instance, because there is a certain design aspect for your application, and your application is going to be dependent on how your application writes and how your application reads to and from the database. But the idea behind DynamoDB is that you use standard HTTP to just do writes and reads in JSON format, and you can store a whole document with multiple keys and values, or you can do a key and value one by one. DynamoDB essentially is designed for web scale applications. It's designed to overcome the problems that you have with traditional SQL databases, where you just can't scale to more than tens of thousands of transactions per second. So with DynamoDB you get the performance, But of course you have to sacrifice ACID compliance. Dynamodb is not ACID, it's base. So base stands for basic availability. Soft state, meaning the state is not determined at all times, it's fluid, it's handled by the application itself. And then of course eventual consistency, E stands for eventual consistency. Now when I say AWS Dynamodb throws ACID out the window and uses base, well, not really, because due to demand there is a way to now run transactional reads and writes against the Dynamodb tables. These can be done per each read and write. You can specify, you know, whatever you want. You can do up to 25 operations in a transaction, and of course those reads and writes are ACID compliant. Now, of course, it breaks availability, so when you're doing your transactional writes, you're going to be making the data unavailable at that point in time, which, you know, is a mix and match of features now at this point. So yeah, basically Dynamodb is a very, very high performance database, and these are typical two databases that we sort of compare one with each other. Now, of course, it wouldn't be called planning and designing databases if you only had two databases, right? We also looked at Documentdb. So Documentdb basically is a managed MongoDB application, MongoDB database. So for any MongoDB compatible applications, you can just hop in, start a Documentdb cluster and run it. Documentdb is designed basically around the same architecture as Aurora. So it's node based, but the storage is decoupled from compute. So you can scale compute independently. You can again have one primary and up to 15 read replicas, same as Aurora. And of course, when would you choose? When would you choose Documentdb over Dynamodb? Well, when you have JSON documents that you're storing, or when you have like MongoDB compatible applications that need that compatibility, or when you have a use case where the cost of running Dynamodb is going to exceed the cost of running Documentdb. Large writes, for example, right? When you have large documents that you're storing, then Dynamodb can become very expensive due to the size of the index, due to the data consumed by the index. And of course, provision capacity units can be expensive. So they can do the same thing, and yeah, it's hard to choose. Now, number three, another key value store is Keyspaces. So Keyspaces is a managed service. It's a serverless design of a Cassandra compatible database. Cassandra compatible database means any application that you have that has key value information, and you used to use Cassandra, but now you want to go to a managed service. It's Keyspaces, right? What you have to consider is that Keyspaces and Dynamodb roughly do the same thing, and Keyspaces, because of its Cassandra compatibility, has about of a 15% uplift in cost. It works in the same ways as Dynamodb pretty much. It has either provision capacity or on-demand capacity, and you know, it supports Cassandra, so there's a little bit of a cost bump due to that. Yeah, we then also took a look at Redshift. Redshift is a columnar database. It's designed for archiving. Now you have out of the box the ability to run volumes up to petabytes, up to 8 petabytes in size. And of course you can scale to basically any size that you want. I'm trying to get around this construction here. Let me see, maybe I can just cut in through here. All right. There we go, that's gonna work. Anyway, as I was saying, with Redshift, it's all about large volumes of data. As you can imagine, when you want to have large SQL-y addressable volumes, where you have large SQL tables, you're going to hit the limitations of RDS, and the limitations of RDS are, for example, with RDS you can only do 64 terabyte volumes, whereas with Redshift, petabytes. So Redshift is very cheap in the long run, and of course Redshift is a good option when you have analytics, when you have OLAP, when you have any kind of large workloads where you want to just use a very cheap cluster to do that. And then finally, there's two new age databases. There's the Quantum Ledger and Neptune. So Quantum Ledger is a ledger. It's sort of like a blockchain, but it's designed as a centralized database. So if you need an immutable history of all the records, all the changes to your objects, then Quantum Ledger is right for you. Neptune is a graphing database, and Neptune is designed for any kind of relationship analysis. Like, for example, you want to analyze your social networks, you want to analyze how your customers map to your product, right? And essentially, yeah, I'm going the wrong way here. Sorry. Need to turn around. I went too far. Anyway, the relationship between how your products matches to your customer, how essentially you can recommend new products to your customers according to, you know, what similar customers bought before. So you can have a relationship between you and your products and other customers and your products, and then analyze what would be a recommended product for this person. So product recommendation. Also, graphing database is great for fraud analysis because it's you know, a customer and their purchases, and if a weird purchase comes up that's not something that will be considered an anomaly in the customer's purchase history, then of course fraud detection can quickly kick in within seconds. Neptune is designed not to store data. Although it can store data, it can store key value pairs, it is more designed to store information about the relationships themselves and to traverse relationships really, really quickly. And then finally, one other type of service that's essentially also a database is Elasticash. Elasticash is an in-memory database service, so it lets you build databases in memory. It lets you essentially build super fast, low latency databases that you can use for offloading your database reads. You can use them for storing information. There's two engines supported, Memcached and Redis. Memcached is a very simple engine. It's a simple key value store. It just has a very simple structure. You send data into a port, a key value information into a port. You say key is name, value is Marco. You send that up to the database, and when you request what is the value for name, and then it will return Marco. That's basically what it does. Whereas Redis is basically more of an in-memory database where you can support advanced structures, where you can support table-like structures and do querying with the Redis client or with Lua scripting language. All right, so I just described all of these databases. Now let's quickly talk about when to choose each of them. Traditional databases are still a thing, right? Not everything has moved to the blockchain. Although blockchain gives you a good record of historical facts and changes about an item or an entity, it doesn't suit all purposes, right? So what you want is you want to have a database that will fit your purpose. And for example, traditional RDS databases, they're great for applications that require them. Dynamodb, great for mobile, for web, for IoT. Documentdb or Keyspaces if you need MongoDB or Cassandra support in your application. Quantum Ledger when you need a ledger, when you need blockchain, when you need a history of all the changes to an entity. And then Neptune if you're doing relationship analysis, social networks, recommendation engines, fraud detection. And then finally Elasticash when you want to speed up any database, because you can always offload some of the records into the cache and make that database operate much faster. All right, that is it. Thank you very much for watching, and I will see you